All right then. So the law of conservation of mass is true because of the law of conservation of matter. We're not going to destroy matter in a chemical reaction. And we're not going to create matter in a chemical reaction. Are we talking about it in class before the test?
Yes.
Then it's on the test. We got 2 days.
Actually, only one.
Well, okay. We got the rest of this period and tomorrow's period, and you got tonight and tomorrow night. Okay. So you will get it today.
I want to go home and play with my grandkids.
In a chemical reaction, matter is neither created or destroyed. Okay? Alright, so the extension of that statement is, you can change it all around, but you can't create or destroy it. Alright? Alright. There's also something called the law of conservation of energy. So I can take electrical energy from the plug in the wall over there, and I can use that electrical energy, run it through a little heater and create heat energy. Or I can run a lamp or a light, and I can turn that electrical energy into light energy. But the energy is not destroyed. The energy is only changed. Okay? So, energy is not destroyed, but it can be changed or moved around. Okay? If I take a piece of paper and burn it, that energy had to come from somewhere. Where did the energy come from to burn that paper? Huh? The energy was in the paper to start with. Well, it's actually in the paper and in the oxygen that surrounds it. So the energy was stored in the chemicals. So here is methane, which I burned when I was doing that hands-on fire demonstration. And I burned it. I created heat over here. That was a product. I did that because there was energy stored in the bonds in these chemicals. We rearranged the chemicals, and in addition to the new chemicals we created, we also created heat. So I didn't destroy any energy. I just used the energy that was stored there. Does that make sense? So we moved it around. We changed it and moved it around. We didn't destroy it. That make sense to you? Well, in the late 1800s and early 1900s, physicists and chemists began to realize that there actually is more than just the law of conservation of mass or matter and conservation of energy. They began to figure out that you can change matter into energy. And they invented something called the atom bomb. Okay, they dropped one on Hiroshima and one on Nagasaki during World War II to end the war. Okay? I don't know, can you? You may go to the bathroom. All right. So, because we can change matter into energy, then these two laws don't work anymore. as they're written. Well, actually they do, because I was careful about saying in a chemical reaction. As long as all we're doing is a chemical reaction, you don't change matter into energy. You have to do a nuclear reaction to change matter into energy. But that brings us to the law of conservation of mass energy. Turns out matter is another form of energy. One of the things I told you guys about was right before school started, they had a big news conference about the discovery of evidence that the Higgs Boson actually exists. Okay. It's a really, really, really tiny particle of mass energy. Okay? You can't see it. They discovered evidence of it, they didn't actually see it. Well, they made a prediction. If the Higgs boson exists, then if I do this, I will get this to happen. They wrote a hypothesis. And they had evidence from the CERN collider in France that they got what they expected to get. Evidence that it exists. Okay, now the Higgs boson is important because the Higgs boson supposedly, according to the theory, creates a Higgs field, which then in turn gives subatomic particles their mass. Okay? That's the theory right now of how gravity actually works. You give it mass by this Higgs field. Okay? Now, that's all stuff way beyond chemistry that you need to know, but I think it's just interesting that it comes up right before we started a chemistry class, and we're talking about law of conservation of mass energy. Okay? All right. Law of conservation of mass energy says that this stuff called mass energy, and it is kind of the same thing. Einstein wrote the equation E equals mc squared, which shows the relationship between mass and energy. The mathematical relationship. Energy is equal to mass times the speed of light squared. Okay, they're kind of two sides of the same coin. They're kind of the same thing. Okay, mass energy is never created or destroyed. Okay? And the corollary to that is that you can move it around. You can change it from one form to another, or from one form of energy to another, but you can't create or destroy energy, or mass energy. The amount of mass energy in the universe is constant. The amount of mass energy in the universe is constant. So if I burn methane and I create heat, all I did was change matter. Well, I didn't change matter to energy. I changed took the energy that was stored here into some energy. Okay, I moved it around. I moved the energy around. Okay, I didn't destroy energy. I moved it around. Okay, now I can take matter. This is how nuclear power plants work. It's how nuclear bombs and atomic bombs work. They change mass into energy. Theoretically, it might be possible to turn energy into matter. We don't have the technology yet, but theoretically it should be possible at some point, or maybe possible at some point. Okay? Does that make sense so far? You with me? The amount of mass energy is fixed. It doesn't change. So you can change one into the other or move it around, but you can't get rid of it. Right? Yeah, these are kind of memorized things here. But see, this right here and this right here, you're supposed to have learned in physical science, so that part's reviewed. I'm just extending it a little bit, refining it, the knowledge a little bit. Okay? You were supposed to learn about the law of conservation of mass and the law of conservation of energy in physical science. If you don't remember it, then this is a review. Oh, it's relearning it, I guess. Okay? Huh? Now, a guy named Lavoisier actually figured this stuff out right here, law of conservation of matter. I think Lavoisier is just really, his whole story is just so cool. Well, I mean, there's just too many stories to tell. His most famous experiment was his last one, when his head was cut off.
What?
See,
I remember talking about
He was a low-level nobleman in France in the at the time of the French Revolution, and despite the fact that he did a lot of good stuff for the poor, when the poor took over France, okay, they beheaded anybody that had a title, okay, and so his last experiment was he had his wife count how long he blinked his eyes after his head was cut off to see how long your head actually survives. Yeah.
How many times did you blink?
It was several of them, about 2 seconds. Okay. Well, that's really dedication to science, isn't it?
But why?
He's also the guy who coined the term chemistry. What? But he's the one that figured out though that about the law of conservation of matter. Essentially, he didn't call it that, but he found out that when people breathe, they're actually doing the same kind of chemical reaction as burning paper. Okay? Because you're breathing in oxygen, you're burning sugar really, and you're giving away CO2. So nothing's lost, it's just converted to something else. All right? So he basically found evidence to dispute what was then called the phlogiston theory, which is that's a whole other story. That's a whole cool story. Anyway, there's a lot of interesting stories about him. We won't get into all of it. Anybody ever been to Paris? Been to the Louvre in Paris?
Mm-hmm.
You know about it? How many of you know what the Louvre is? Okay. The most famous art museum in the world, probably. Okay. If I'm not mistaken, they set up the that was an old castle, and they set up the guillotine that beheaded him there in that courtyard. I'm not sure. I'm not certain of that. I'm not. Don't hold me to that, okay? But anyway, I've been to Paris, and I've been in one of those places. It's really cool. And Lavoisier's name is one of those scientists' names that's on the Eiffel Tower. If you ever go to the Eiffel Tower, that first level of the Eiffel Tower, in huge iron plates, they're the names of many, many famous French scientists listed on there. Lavoisier, Le Chatelier, Laplante, all these people. Really cool. Anyway, I didn't know that when I went there. And here I am, I'm going to this little restaurant before going to the Eiffel Tower, and I look around the corner, and there's the Eiffel Tower, and I see all these names that I recognize. I'm going crazy, and I want to say, what? Okay. All right.